Preparing for a Node.js developer interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How does the Node.js event loop work, and why is it important? The event loop is Node.js's concurrency engine. It lets one JavaScript thread handle many connections by delegating I/O to the OS or libuv thread pool, then running callbacks when work completes. I explain phases like timers, poll, check, and microtasks because ordering affects bugs. CPU-heavy code blocks the loop, so I move it to worker threads, child processes, or separate services. For APIs, keeping handlers non-blocking is critical. While answering, focus on single-threaded execution, libuv, event loop phases, callback queues, microtasks, non-blocking I/O, and why CPU-heavy tasks can hurt API responsiveness. Question 2. What are streams in Node.js, and when would you use them? Streams solve the problem of processing large data without loading everything into memory. For example, instead of reading a 2 GB file fully, I can pipe a readable stream into a writable stream chunk by chunk. Node supports readable, writable, duplex, and transform streams. I use them for file uploads, log processing, compression, and HTTP responses. The key detail is backpressure. The producer must slow down when the consumer cannot keep up. Make sure to cover readable, writable, duplex, and transform streams, memory efficiency, piping, backpressure, file uploads, large downloads, and real-time data processing use cases. Question 3. How does middleware work in Express.js? Middleware is a function that runs between the incoming request and the final response. In Express, it receives rec, res, and next, so it can modify the request, send a response, or pass control forward. Ordering matters because middleware executes in registration order. I commonly use it for logging, authentication, validation, parsing JSON, and centralized error handling. A common mistake is forgetting next or not returning after sending a response, which can cause hanging or duplicate responses. In your answer, talk about request-response lifecycle, next function, ordering, route level versus app level middleware, error middleware, authentication, logging, validation, and response termination. Question 4. How do you handle errors in async await code in Node.js? With async await, rejected promises behave like thrown errors, so I wrap awaited operations in try-catch or use an async route wrapper. In Express, I prefer forwarding errors to centralized error middleware instead of repeating response logic everywhere. I separate operational errors, like validation or database timeouts, from programmer bugs. I log enough context, return safe client messages, and avoid swallowing errors silently. For production, I also monitor unhandled rejections and fail fast when state is unsafe. Be sure to mention try-catch, rejected promises, Express async wrappers, centralized error middleware, operational versus programmer errors, logging, status codes, and avoiding swallowed errors. Question 5. What is the difference between CommonJS and ES modules in Node.js? CommonJS uses require and module.exports, while ES modules use import and export. CommonJS loads modules dynamically and synchronously, which fits Node's older ecosystem. ES modules are statically analyzable, support top-level await, and align with browser JavaScript. In Node, the package.json type field and file extensions decide module behavior. I choose ES modules for new projects, unless compatibility with older libraries or tooling makes CommonJS simpler. Mixed module systems need careful interop testing. While answering, compare require and module.exports with import and export, loading behavior, static analysis, package.json type field, interoperability, top-level await, and migration considerations. Question 6. What is the role of package.json and package-lock.json in a Node.js project? Package.json describes the project, scripts, metadata, dependencies, dev dependencies, engines, and configuration. Package-lock.json captures the exact dependency tree installed, including transitive versions, so builds are reproducible across machines and CI. I use npm install during development when changing dependencies, and npm CI and CI because it installs exactly from the lock file. Version ranges in package.json give flexibility, but the lock file gives stability. Both are important for secure, repeatable deployments. Make sure to cover dependencies, dev dependencies, scripts, semantic versioning, lock file reproducibility, npm install versus npm CI, metadata, engines, and security audit relevance. Question 7. How would you scale a Node.js API to handle high traffic? I start by making the API stateless so multiple instances can run behind a load balancer. On one machine, clustering can use multiple CPU cores, but real scale usually means horizontal replicas in containers or VMs. Then I remove bottlenecks with caching, database indexes, connection pooling, and background queues for slow work. I also add metrics for latency, event loop lag, error rate, and saturation. Scaling Node is less about threads and more about architecture. In your answer, discuss stateless services, horizontal scaling, load balancers, clustering, caching, database bottlenecks, queues, connection pooling, observability, and graceful shutdown. Question 8. When would you use worker threads instead of child process in Node.js? I use worker threads for CPU-bound JavaScript work, like image processing, encryption, parsing, or complex calculations that would block the event loop. Workers run in separate threads and can share memory using shared array buffer, which is efficient but needs care. Child process gives stronger isolation because it starts another process, useful for running shell commands or unsafe workloads. Workers are lighter, processes are safer. For heavy recurring jobs, I normally use a pool rather than creating workers per request. Be sure to cover CPU-bound tasks, shared memory, process isolation, startup overhead, communication cost, crash containment, worker pools, and when external services may be better. Question 9. How do you detect and fix memory leaks in a Node.js application? A memory leak usually shows up as heap usage growing after traffic returns to normal. I first check metrics, then reproduce with load tests and capture heap snapshots. Common causes are unbounded caches, global arrays, timers, closures retaining large objects, and EventEmitter listeners not being removed. I compare snapshots to find retained objects and allocation paths. The fix is often simple: limit cache size, remove listeners, core timers, or avoid storing request scope data globally. While answering, focus on heap growth, garbage collection, retained references, global variables, listeners, caches, heap snapshots, Chrome DevTools, Clinic tools, and production monitoring. Question 10. How would you implement authentication and authorization in a Node.js REST API? I separate authentication, which proves identity, from authorization, which decides access. For login, I hash passwords with bcrypt or argon2 and never store plaintext. For APIs, I may use JWTs with short expiry plus refresh tokens or server-side sessions for stronger revocation. Express middleware verifies the token, attaches the user context, and checks roles or permissions. I also enforce HTTPS, secure cookies when used, rate limiting, secret rotation, and careful error messages. Make sure to cover password hashing, JWT versus sessions, refresh tokens, middleware, role-based access, token expiry, secure cookies, HTTPS, secret management, and common security mistakes. Question 11. What practices do you follow when designing REST APIs in Node.js? Good REST design starts with resources, not actions, users, orders, and orders.id. I use HTTP methods correctly, return meaningful status codes, and keep response shapes consistent. Inputs are validated at the boundary, and list endpoints support pagination, filtering, and sorting. For reliability, I consider idempotency for retries, especially on payments or order creation. I version APIs only when needed, document contracts with OpenAPI, and avoid breaking clients accidentally. In your answer, talk about resource-based URLs, HTTP methods, status codes, validation, pagination, filtering, idempotency, versioning, consistent errors, documentation, and backward compatibility. Question 12. What are common security risks in Node.js applications, and how do you prevent them? The biggest Node security issues are usually not Node-specific. Injection, broken auth, exposed secrets, unsafe dependencies, and poor input validation. I validate and sanitize input, use parameterized database queries, configure cores tightly, and set secure headers with Helmet. For browser-facing apps, I handle XSS and CSRF depending on the auth model. I scan dependencies, rotate secrets, rate limit sensitive endpoints, and avoid logging tokens or passwords. Security is a default posture, not a final checklist. Be sure to mention input validation, injection, XSS, CSRF, dependency vulnerabilities, secrets, rate limiting, Helmet, cores, authentication flaws, logging hygiene, and least privilege. Question 13. How do you manage database connections efficiently in Node.js? I avoid opening a new database connection for every request. Instead, I create a shared connection pool at application startup and reuse it across handlers. The pool size should match database capacity, not just API traffic, because too many connections can slow everything down. I set timeouts, use transactions for multi-step consistency, and close pools during graceful shutdown. Whether I use Prisma, Sequelize, Connects, or native drivers, I monitor query latency and connection saturation. While answering, cover connection pooling, ORM versus query builder, transactions, retries, timeouts, prepared statements, avoiding per-request connections, graceful shutdown, and monitoring database saturation. Question 14. What is EventEmitter in Node.js, and where is it useful? EventEmitter is Node's built-in pattern for emitting and listening to named events. It helps decouple producers from consumers. One part emits user.created, while multiple listeners send email, audit logs, or analytics. Streams, servers, and many core modules use this model. I always handle error events, because unhandled error events can crash the process. I also remove listeners when they are no longer needed, since accumulating listeners can create memory leaks. Make sure to cover publish-subscribe style, on and emit, error events, listener cleanup, memory leak warnings, asynchronous design, streams, and decoupling internal application components. Question 15. What is backpressure in Node.js streams, and how do you handle it? Backpressure happens when data is produced faster than it can be consumed. If ignored, buffers grow, memory spikes, and the process may crash under load. Node streams handle much of this automatically when using pipe, because the writable stream signals when it needs the readable stream to pause. When writing manually, I check write's return value and wait for the drain event before continuing. Tuning high watermark can help, but respecting flow control is the real fix. In your answer, discuss producer-consumer speed mismatch, memory growth, stream buffering, pipe, drain event, high watermark, async iteration, and why ignoring backpressure causes production issues. Question 16. How should a production Node.js service handle uncaught exceptions and unhandled promise rejections? An uncaught exception means the process may be in an unknown state, so I do not simply log and continue forever. I log the error with context, stop accepting new requests, finish in-flight work briefly, close database and server connections, then exit. A process manager like PM2, Systemd, Kubernetes, or ECS restarts it. For unhandled rejections, I treat them seriously too. The best approach is prevention through consistent async error handling and strong observability. Be sure to cover process stability, centralized logging, graceful shutdown, rejecting new requests, closing connections, crash-only design, process managers, alerts, and avoiding blind continuation. Question 17. How do you test a Node.js application effectively? I test Node applications in layers. Unit tests cover pure business logic, with mocks where useful. Integration tests verify routes, database behavior, and middleware, using tools like Jest, Mocha, and Supertest. For external services, I mock at boundaries or use contract tests. I prefer a disposable test database or containers over sharing dev data. Good tests are deterministic, fast enough for CI, and focused on behavior rather than implementation details. Coverage matters, but meaningful assertions matter more. While answering, focus on unit tests, integration tests, end-to-end tests, mocking external services, test databases, supertest, jest or mocha, coverage quality, CI, and deterministic tests. Question 18. How would you add caching and rate limiting to a Node.js API? I add caching where repeated reads are expensive and freshness requirements allow it. Redis is common for distributed caching, with clear cache keys, TTLs, and invalidation rules. For public responses, HTTP caching headers can reduce load even before traffic reaches Node. Rate limiting protects the API from abuse and accidental spikes. I usually implement per IP, per user, or per token limits using Redis, so limits work across instances. The trade-off is always freshness versus performance. Make sure to cover Redis, cache keys, TTL, invalidation, HTTP caching, per user and per IP limits, token bucket, distributed rate limits, and protecting expensive endpoints. Question 19. How would you use queues in a Node.js backend, and what problems do they solve? Queues move slow or unreliable work out of the request path. For example, after an order is created, the API can enqueue email, invoice generation, and webhook delivery, then respond quickly. Workers process jobs asynchronously using tools like BullMQ with Redis, RabbitMQ, or Kafka. I design jobs to be idempotent because retries can happen. I also configure backoff, dead letter queues, and monitoring. Queues improve resilience, but they introduce eventual consistency and operational complexity. In your answer, discuss background jobs, retries, idempotency, dead letter queues, message brokers, BullMQ, RabbitMQ, Kafka, eventual consistency, and keeping request latency low. Question 20. How do you profile and improve the performance of a Node.js application? I start with measurement, not guesses. First, I check latency percentiles, throughput, error rates, CPU, memory, event loop lag, and database timings. Then I profile using Nodes Inspector, Clinic.js, Flame Graphs, or APM tools to find hot paths. Common fixes include optimizing slow queries, removing synchronous file system or crypto calls, adding caching, reducing JSON payload size, and moving CPU work off the main thread. I verify improvements with load tests before calling it done. Be sure to mention measuring before optimizing. CPU profiles, heap snapshots, event loop lag, slow queries, logging overhead, load testing, caching, flame graphs, and production-safe observability. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.